At this problem today, the first thing we're going to do is make a word equation for our problem here. So we have sodium sulfide plus iron nitrate. Can't forget so sodium sulfide AQ plus iron 3 nitrate AQ is 2 reacts, and we put that arrow here. This is our reactants on the reactants rows on the right, and then products on the left. So on the left we have the products of iron 3 sulfide and the sodium nitrate. The AQ is for aqueous solution, and the S is for solid. This is a double displacement reaction, also could be called an exchange reaction. This is going to occur when parts of two ionic compounds are exchanged, making two new compounds. You can think of it as like swapping half. And then so we're going to name the formulas of our reactants. So we have Na2S for sodium sulfide. The Na represents sodium with the subscript 2, which indicates there are two sodium atoms in each molecule of sodium sulfide, and the S represents our sulfur there. So we have Na2S. It means that in each molecule of sodium sulfide, there are two sodium atoms and one sulfur atom. And then we have our iron nitrate, which is Fe parentheses NO3, which is our Fe is our iron, and then in our NO3, this part represents the nitrate ion. So we have the NO3 with the subscript 3 outside of the parentheses. That indicates there are 3 nitrate ions in each molecule of iron 3 nitrate. So FeNO, and then parentheses 3 signifies in each molecule of iron nitrate there is 1 iron atom and 3 nitrate atoms, if that makes sense. And then we're going to be naming the formula of our products. So first, we have the iron sulfide, which is Fe2S3. The Fe2, that represents 2 iron atoms, subscript 2 because 2. And then there are, we have the S3, this represents 3 sulfur atoms. And then we have our sodium nitrate, which is NaNO3. Na, that represents a sodium, which we do know is a metal. And then we have the nitrogen ion, or the nitrate ion, which consists of nitrogen and 3 oxygen atoms. But in this chemical formula, the nitrate ion is represented as a whole entity with a single formula unit. So NO3 signifies that in each molecule of sodium nitrate, there is 1 sodium and 1 nitrate ion of NO3. Now that we know what our reactants and products are, it is time to balance the equation using the milliliters and everything they gave us in the beginning. So doing that, we need to know that our aqueous is the aqueous solution and the S is the solid. So in this chemical equation, it means that the sodium sulfide and iron nitrate and sodium nitrate are all dissolved into water. That's what the aqueous solution means. And then the solid is a solid, so it's not dissolving into water. And then the balanced equation indicates that there are 2 moles of sodium, 2 moles of sodium sulfide react with 3 moles of iron nitrate to produce 1 mole of iron 3 sulfide and 6 moles of sodium nitrate. The states of matter symbols helps to represent what is physically coming out of our reaction. And then continuing on, we're going to use our coefficients here. So to help us answer both question 7 and 6. So we know that in the equation, we see that for every 3 moles of iron 3 nitrate, there are 6 moles of iron 3 sulfide produced. So we're first going to find the moles of our, we're first going to find the moles of our iron nitrate. So we know we have the 0.125 moles of the sodium sulfide, and that we can multiply that by 3 because of what I just stated before. So we can cross multiply here, which is going to bring us out to 0.375 moles of our iron nitrate. And then now we need to convert to grams using the molar mass for 7. This is question 7 right here. So now convert to grams using molar mass, knowing that we have twice as many iron sulfide as iron nitrate. So molar mass of our Fe2S3. So 2 times, when we break this down, we have 2 iron, which is 55.85, and then 3 sulfur, which is 32.06. Multiply 2 times that, 3 times that. It's going to bring us out to 207.82 grams per mole. That's our molar mass. And then, so we're going to multiply the molar mass times how many moles we have in our problem, which brings us out to 25.98 grams of iron sulfide. And then the number of iron atoms in iron 3 sulfide, we have the 2 moles per formula unit. So 0.125 moles of iron sulfide times 2 equals 0.25 moles of iron. And then we're going to cross multiply again here using our molar formula that we already know. So 0.25 iron, we cross out the iron, giving us 1.51 times 10 to the 23rd iron atoms.